Hello friends. So in today's video we will see how to find the middle of a linked list. So for this question I hope the basics of linked list are clear to all of you, and now we will see how to find the middle of any linked list, and we will consider the linked list as a singly linked list. So let's just see the code. Okay, so as you can see, what we have to find the middle of a linked list, that is singly linked list. So in this example, as you can see in this example, the middle is this element. This element is the middle of the linked list. So how we can do this? So the first approach is very simple, and we can say it as a naive approach, where what we have to do, we have to traverse the whole linked list and count the number of nodes. So we will take a variable, that is count variable, and we will keep on incrementing it whenever we found a node. So the second time we will again traverse the linked list till count divided by 2. This means the half. So here there will be two iterations. One will be to find the count and second will be to find the middle of the linked list. So this is a very basic approach, and in the second approach we will see. So mostly this approach is used. As we can see, what we have to do, we have to traverse the linked list using two pointers. One will be called a fast pointer and the second will be called a slow pointer. Okay, so what we have to do, we have to move one pointer by 1 and the second pointer by 2. As you can see here, the first pointer will be moved by 1 and the second pointer will be moved by 2. So the slow pointer will be moved by 1 and the fast pointer will be moved by 2. So what will happen after this? We will see when the fast pointer, that is moving by 2, when it reaches the end, the slow pointer will reach the middle of the linked list. This is the whole concept of finding the middle of a linked list. This is a very good approach, and you may find this approach is also called rabbit and turtle approach. So let's just see how we can use this approach and find the middle of a linked list. We will use the second approach, because I hope this first approach will be clear to all of you. It is a very easy approach. So this is a code to implement the two pointer technique. Okay, what we have to do, we made a function here, that is get middle function, and it will return an integer value. Here we pass the head, the first node. Okay, now we took two pointers here. One is slow pointer and one is fast pointer. As I told you, the first pointer will be moved by 1, that is the slow pointer, and the second pointer, which is a fast pointer, that will be moved by 2. So first of all, we have to check the condition that if head is not equal to null, that means the linked list is not empty. Because if it is empty, we cannot find the middle of the linked list. So if head is not equal to null, then what we have to do, we have to traverse a while condition. As I told you, we have to traverse, so we will use a while condition for that. And what will be our condition? The condition will be while the fast pointer is not equal to null, that the fast pointer should not be equal to null, and here we have used the AND operator, and the next of the fast should also not be equal to null. If these two conditions are getting satisfied, only then we will traverse our linked list. I hope this line is clear to all, because if any one of these conditions is false, we have to stop, or it means that we will reach the end of the linked list. So what we have to do in this loop, we have to increment the fast pointer to fast next to next. Are you seeing here? This is what I was talking about, that we have to increment it by 2, and the slow pointer we have to increment it by 1. See, this whole is the concept here. If you know this concept, you can write the code easily, and I hope this code is understandable. So when the whole linked list is traversed and the fast pointer reaches to the end, this means the slow pointer that was moving by 1, that is at the position which is middle of the linked list. So after this traversal, what we have to do? We have to return the data of the slow pointer. Are you getting my point? The slow pointer will return the data, and the data will be the middle of that linked list. So here, as you can see, let's implement the code first, as I said. So I've taken 2 pointers. This is my slow pointer and this is my fast pointers. And you must know the middle of the linked list is 30 here. Okay. So as I said, move the slow pointer by 1. So this will be here, and the fast pointer will be moved by 2. So this will be here. In the second iteration, the slow pointer will be at 30 and the fast pointer will be at 50. So now we see the next of the fast pointer is null. So we will not carry forward. We will stop here. And as you can see, our slow pointer here, you see, our slow pointer is at 30 and this is the middle of the linked list. So I hope this is clear, and linked list can be of any size. This I have taken a small size because of the implementation constraints and because I don't want to take a lot of time, but you can check for any linked list, this code will work. Alright, so let's just see the code if it works on the Geeks for Geeks platform. I have made my account on Geeks for Geeks and we will try to run our program on this platform. So I have copied and pasted this code here. As you can see, this is the same code, and I'll provide the link in the description as well. But here you can see I have pasted the same code as I taught you, and let's just try to submit it. And if it gets submit, that means our code is working fine. As you can see here, my code worked fine and it got accepted by the compiler. So guys, I hope this video was useful to you, and if it video was useful to you, please subscribe to my channel and like this video. Thank you friends.